Hello everyone, today I am going to explain the polar coordinates, the relation between the Cartesian and the polar. So you are having any point xy in Cartesian plane, in xy plane. Let's suppose this point is this one, having the coordinate x and y. Then we can express this point in polar by considering this origin to be as a pole and this x-axis as a initial ray. Let's suppose this is an angle theta and this distance is r, which is the square root of x square plus y square under root. So if we want to find out the coordinate of this point P in polar, then this is represented by r comma theta, where the value of r is x square plus y square under root and the value of theta is tan inverse y upon x. Here this r, it is a distance, directed distance from the pole O to the point P, and this theta, this is the directed angle from the initial ray to OP, right? So if you are having any point in Cartesian coordinates where x and y, then we can put x to be r cos theta and y to be r sin theta, and we can convert the Cartesian equation into polar having the coordinates r and theta. Similarly, if we are having any equation in polar, we can convert it into Cartesian by substituting r to be x square plus y square under root and theta to be tan inverse y upon x. So this is a relation between polar and Cartesian. Now just see with the help of an examples. For example, we have to find the Cartesian equation of this polar equation. So let's suppose r cos theta is equal to 2. So what is the form in Cartesian? Since we know that r cos theta is nothing but x, so it is an equation of line, horizontal line x is equal to, vertical line x is equal to 2. So r cos theta is equal to 2 in xy plane. Basically it is a line x is equal to 2, right? And this line is represented in polar. So this is your initial ray, this is your pole. R cos theta is equal to 2 means this line x is equal to 2 in Cartesian. Similarly, if you are having any equation in polar, r square cos theta into sin theta is equal to 4, we can convert into Cartesian by substituting r cos theta to x and r sin theta to y. So this is your x, this is your y. So this is x into y is equal to 4. So this is the equation in Cartesian. Similarly, if we are having an equation r is equal to 1 minus cos theta, then we can put r to be x square plus y square under root and cos theta to be x upon, since we know that r cos theta is equal to x, so cos theta is equal to x upon r. So this will be x upon square root of x square plus y square. We can more simplify this. We can again take the square, we can again squaring both sides and we can more simplify this. Or or we can write this as we can first we can take its square. So this will be 1 plus cos square theta minus 2 cos theta is r square, and then we can substitute the value. So one and the same thing. So we have to substitute r to be x square plus y square under root, and cos theta is x upon r, so we can substitute this and we can simplify this. We can more simplify this by taking the squaring to both sides. One more example. We are having equation r is equal to 1 plus 2r cos theta. So convert this polar equation into Cartesian. So this can be written as x square plus y square under root 1 plus, this is nothing but x. Now we can take the squaring both sides. Four x, and we can more simplify this by opening this. So this is the equation in Cartesian and this is the equation in polar. Similarly, we can convert Cartesian into polar. For example, find the polar equation of this. We can open this square. It is y square plus 9 minus 6y is equal to 9. This 9 cancel out. Since x square plus y square is r square and y is r sine theta, now we can take r to be common. So from here either r is 0 or r is 6 sine theta. Since r is equal to 0 is included over here, right? Since this includes r is equal to 0, so this is the equation in polar. So this is a Cartesian into polar. Now one more example. Let's suppose r cos theta is equal to minus 4. What's the Cartesian form of this? This is x is equal to minus 4. Right? Similarly, if Cartesian equation is given to us, we can convert into polar by substituting x square plus y square to be r square, or x is equal to r cos theta, y is equal to r sine theta, right? Or theta to be tan inverse y upon x. So we are having this relation in Cartesian and in polar. But in polar, there lie infinitely many representation of a single point P. Let's suppose P is any point having the coordinates r and theta, where theta is an angle from the initial ray to the line OP, and OP is a distance, forward distance r. Right? How we will reach at this point? This is initial ray. We are at present at this point. We move angle, let's suppose pi by 2, 90 degree, and then we take two steps, one step and two step. Then this, the coordinate of this point is 2 comma pi by 2. So this is point P. After taking a turn 90 degree and after covering the distance 2 step, we will reach at point this. This is a one representation of the point P, but one can reach at this point by moving such angle. How much angle is this? This is 2 pi minus pi by 2, which is 3 pi by 2. It is 2 pi minus pi by 2, which is 3 pi by 2. But in clockwise direction, so we know that whenever we are moving clockwise we consider theta to be negative, and when we are moving anti-clockwise we consider theta to be positive. So clockwise we measure theta negatively, and anti-clock or counterclockwise theta is positive. So if we are moving clockwise, so the angle is 3 pi by 2 with negative sign. So we reach at this point in this direction. Now we have to take 2 steps and we will reach at this point. So another representation of this point is 2 comma minus 3 pi by 2. So this is another representation of a single point P. However, in Cartesian it is unique form. But in polar we are having infinitely many representations of a single point. Right? So if we turn pi by 2 and cover two step, we will reach at the point P. Another way to form at this to reach at this point is you can turn minus 3 pi by 2 and then you can consider 2 steps, you will reach at the point P. The another representation is one can move such angle, since it is clockwise, so it will be minus of pi by 2. Now our direction, our face is here, not in this direction, but since we have taken the turn this much, so our face is point out this side. If we want to reach at the point P, we have to cover the backward distance, and backward distance is denoted by negative value of r. Right? Backward distance is denoted by negative value of r. So this is the initial ray, this is the pole. If we want to if we want to reach at the point P by backward distance, we have to move such angle. Now when we take a turn minus pi by 2, face is directed this word, and if we want to reach at the point P, we have to cover the back distance. We have to take 2 back steps, then we will reach at this point. Since backward distance is denoted by negative value of r, and here the turn is minus pi by 2, so this is the another representation of a point P. Another way to reach at this point is we can take a turn this. Now since it is anti-clockwise and this angle is 3 pi by 2, and again our face is directed the line minus pi by 2, so if we want to reach at point P, we have to cover the back distance. So again minus 2 with an angle 3 pi by 2. So what we observe we are having 2 forward distance and 2 backward distance points, 2 with the clockwise direction and 2 with anti-clockwise direction. So these all are the representation of a single point P. So once again see, this is the initial ray, this is the pole, this is any point P having the coordinates r and theta. So one can reach at this point by taking a turn theta and then covering the distance r, and one can reach at the point P. The another way, one can take a turn this much angle, this is 2 pi minus theta with negative sign, and then the face is toward this line, and one can cover a distance r and one can reach at the point P. The another way to reach at the point P, take a mirror image of it you can take a turn this much. This angle is pi minus theta with clockwise direction, so this is negative of it, and our face is in this direction. So if we want to reach at P, we have to cover a back distance. So back distance is denoted by minus of r, and the angle is pi minus theta with minus sign. Or one can reach by taking a turn this is pi plus theta. Again the direction is this one. Our face is in this direction. So if we want to reach at the point P, we have to cover a backward distance, and backward distance is denoted by minus of r, and the angle is pi plus theta. So these are the four representations of a single point B by taking two forward distance and by taking two backward distance. The another way to reach at the point P is what? One can take a complete turn and then take a turn theta, and then after covering the distance r, one can reach at this point. So r theta plus 2 pi is again another representation of a point P. Similarly, one can take two turns, means 4 pi, and then move angle theta, and after covering the distance r, again one can reach at the point P. So this is another representation. So after taking one turn, two turn, three turn, four turn, and so on, and moving the same angle theta, one can reach at the point P. So we can add, in theta we can add 2n pi. In every representation we can add 2n pi. So these are infinitely many representation of a single point. So this is the major difference between the Cartesian and polar. In Cartesian, the point is represented uniquely. However, in polar, it is represented by infinitely many ways. One can take one turn, two turn, three turn, and after moving the same angle, one can reach at the same point. So this P has infinitely many representations. Now just see with the help of an example. Find all the representations, all the polar coordinates of the point P 2, pi by 6. Now just see in forward direction. This is 2, pi by 6. So another representation of this point 2, pi by 6 is 2, pi by 6 plus 2n pi, where n is varying from 0, plus minus 1, plus minus 2, and so on. For all these, we will reach at the same point, this P. Right? The another representations are by considering the backward distance. So for the backward distance, the turn is this one. This is pi minus pi by 6 with negative sign. So this is minus 5 pi by 6, and then cover the backward distance, you will reach at the point P. So then representation is minus 2, minus 5 pi by 6. So again in this point, If you add 2n pi, where n is varying from 0, plus minus 1, plus minus 2, all these are the another representation of the point P. So these are the representation of the point P with forward distance, and these are the representation of point P with backward distance. So all these are the polar coordinates of this point P, 2 comma pi by 6. So there lie infinitely many representations of a single point in polar. This is the basic difference between the Cartesian and polar.